starting the Cisco SD-WAN solution training. And before we proceed through the training, let's see what we are going to cover. So the content that we are going to cover, how we are going to cover the time duration, labs, and everything. Let's talk about that first, and then we will talk about. Then we will start the content actually. For example, like if you want to build your own lab at your home, what things will be required? Okay, so that things are easily accessible and everything. We'll talk everything about that, and then we will begin. So the content, there are total in our Cisco SD-WAN solution training. Remember that Cisco offers two types of SD-WAN solutions. One SD-WAN solution is based on Viptela, and the other SD-WAN solution that they offer is based on Meraki. So Meraki based SD-WAN and Viptela based SD-WAN. Typically speaking, Meraki is for like small businesses, small corporate networks, and Viptela is comparatively for large scale enterprise networks. There are other differences as well. We will try to cover a few of them, but a point is that here we are going to cover Viptela based SD-WAN offered by Cisco. There are other vendors as well that offer the SD-WAN solution. Currently, we'll talk about the Cisco SD-WAN based on Viptela. Viptela was a dedicated entity, dedicated company earlier. Cisco acquired Viptela, I believe, in 2016-17, somewhere at around that time. And then it became Cisco SD-WAN Viptela, or generally just known as Cisco SD-WAN. So as per the content, we have to cover total, like first unit that we have to cover in the Cisco SD-WAN Viptela is this architecture, SD-WAN architecture. Then we'll talk about deployments of the controller. Then we talk about the router deployment. Then we talk about policies. And then we talk about security and quality of service. And at the very end, we will talk about the management and operation, typically day 2 operation. So the entire content is divided into total 6 units, 6 parts, you can say. Every part focuses on the important concept, some concept of the SD-WAN. For example, the first unit that we have here, the architecture unit, it focuses specifically on the SD-WAN architecture. Like, for example, why we need SD-WAN, what was the sudden requirement of having the SD-WAN in a production environment? Was there any other type of solution before the SD-WAN that was able to perform the same thing? What are the components of the SD-WAN? What is this orchestration plane, management plane, control plane, data plane, and how in the SD-WAN they are facilitated? For example, what is this orchestration plane and who facilitates the orchestration plane functionality in the Cisco SD-WAN? What is this management plane and control plane and data plane, and what components of the SD-WAN actually facilitates those management plane, control plane, and data plane responsibilities. Then some general terms about the SD-WAN, just like T-lock. You can, just to give you the idea, you can compare this T-lock with the next hop that you have in a typical routed environment. We have a concept called next hop, similar to that we have here in the concept T-lock. In typical enterprise network, we have, for example, management plane, which is responsible to handle the device management. That is a dedicated controller here in SD-WAN, and that controller is known as vManage NMS, Network Management Station. Some people call that vManager or vManage. So vManage is the management plane. It is a controller that Cisco, V stands for Viptela. So originally Viptela came with this idea. But nowadays, since it is Cisco, I will refer to as Cisco. So in the Cisco SD-WAN solution, the management plane functionalities are handled by a dedicated controller called vManage. In the Cisco SD-WAN solution, control plane functionalities are centralized and handled by a single controller called vSmart. In the Cisco SD-WAN solution, the routers that we deploy at the edge of our company to connect us to the internet or other private WAN services such as MPLS. The routers that we connect there, these routers are what we call as the V-Edge router, Viptela Edge router. So Viptela operating system was there. So routers running Viptela operating system, not the Cisco IOS. Those routers are what we call V-Edge router. Cisco also created a few routers that actually can perform the same task as the V-Edge router, and they call that router as the C-Edge router. In short, data plane, these are the routers which are responsible to forward the data inside and outside of the company. And Two types of router you may see in your production environment in the SD-WAN with Cisco SD-WAN. One is VH router, one is CH router. VH router, Viptela operating system based edge router, and CH router, Cisco IOS XE SD-WAN based router that you can have in your production environment. So like how this is a dedicated device. This is not a controller. When it comes to the controller, it is only vManage, vSmart, and there is something called vBond. We'll talk about that later. But there are three controllers in the Cisco SD-WAN solution. In the first unit, we will talk in detail about all these components and some general terms, just like T-lock. I said that T-lock is equivalent to the next hop that we have in our normal routed environment. Ipsec, you must already know, provides it like a security when we transmit the traffic from one point to other point. BFD, bidirectional forwarding detection for faster convergence. vRoute, typically called Viptela routes or VPN routes or service side routes. There are different terminologies for the same. So typically the routes that we get from one edge router to other edge router, those routes are referenced as the vRoute or Viptela route. We'll talk more about in detail about these terminologies, but just to give you the idea, these are the components that we will be using in our Cisco SD-WAN solution deployment. And then capabilities and everything, like what are the VH routers, what are the CH router, what models are available, what capabilities are there. Will we be able to configure, for example, EIGRP in Net or not? So all the capabilities that we can have on the devices. We'll basically go through a data sheet, and in that data sheet we will see the hardware specification and the software capabilities of the VH routers and the CH routers. And finally, how can we extend our SD-WAN solution to the cloud services? Because in a modern day network, almost like everything is about cloud. Services are being ensured, services are running on the cloud. In fact, infrastructure is running on the cloud. Companies are renting these spaces, and they are instead of having their own infrastructure, they are renting these spaces from some big data center, and they are installing their resources, installing their switches, infrastructure, firewalls, and everything there. So cloud networking or cloud computing or cloud, basically like cloud is a very popular thing in now modern day network. So for example, if you have deployed SD-WAN solution in your production environment, maybe you have 100, 200 branches, a few headquarters, data centers, and now you have deployed SD-WAN everywhere so that you can have a centralized control over all the aspects of the managed router. How can we extend the capabilities of the SD-WAN onto the cloud? Means like what things we should do or what can we do so that the softwares that we have deployed onto the cloud, the infrastructure that we have deployed on the cloud, and maybe some other resources that we have deployed in some shared data center onto the cloud, how those things are going to be, how those things are going to be connected to the SD-WAN. So again, this is a described thing. This is, as you can see, this is a described thing. But we will do practically this and this. We will not be able to do practically this, because in that case, I have to rent a data center and then deploy some devices there. So we will not be able to do that. But in fact, we don't need to, as it says only describe. So I will just show you how it is done, but we will not be able to do that. So these two things, we will be able to do that practically. So this is the first unit. As soon as we are done with that, this is the first unit will be done. So from the architecture point of view, once we get all the things known to us, like components and everything, then we will focus on the deployment. How can we deploy the controllers? How can we deploy the routers? Obviously, routers on the edge of our network. So that can connect us to public networks such as internet, that can connect us to the private networks such as MPLS. So how can we deploy the routers on the edge of our, for example, infrastructure? Describe the managed router deployment, onboarding, orchestration with a process called ZTP, zero touch provisioning. Zero touch provisioning is a concept, or PNP. One is for VH router, one is for CH router, Viptela operating system based router, and iOS XE SD-WAN operating system based router. Basically one for Viptela devices and one for Cisco devices. So ZTP or PNP, these two processes actually allow us to just deploy the device onto the branch, make it internet reachable, and everything else will be provisioned automatically. All the other concepts, all the other things are going to be provisioned automatically. So we'll talk about this. We'll talk about this vEdge and cEdge router ZTP process. ZTP stands for zero touch provisioning, or PNP stands for plug and play. Both the things we can use to deploy the routers in our production environment with a minimum user intervention, minimum user interaction, you can say. So what type of topology, or where should we deploy the routers in our data center? Where should we deploy the routers in the regional hub? And the additional concepts such as one vEdge router is going to form an IPsec tunnel to the other vEdge router so that the traffic from one branch is secured while being sent to the other branch. And this tunnel is automatically formed. This is an IPsec tunnel. I don't even have to do any configurations of the IPsec for this tunnel to be formed. So, but that is going to be a permanent tunnel. If you have thousands of, let's say, for example, S devices, all of those S devices will form the IPsec tunnel to every other S device in your SD-WAN deployment in a full mesh fashion automatically. We don't even have to do anything. So what if, for example, I want to have dynamic tunnels? What is the concept of underlay and overlay? All that will come in the router deployment. And in the controller deployment, we will see, I'm not going to deploy my controller onto a branch. I can do that, but I'm not going to typically deploy my controllers into a branch. Maybe I will deploy my controllers in a data center, headquarter, or some cloud. So what things you should consider when you deploy your controller, maybe, for example, on cloud? What things should you consider when you deploy your controller, for example, maybe on premises, in your data center, in your maybe some headquarter network, wherever? What are the hosting platforms like KVM hypervisors? How can we install the controllers and everything? Remember, describe, and here is what we have to configure. Once we deploy the controllers, let's say we have deployed the 3 controllers, these 3, and we have some edge devices as well, for example, VS devices and CS devices. We have deployed our controller maybe in a data center. We have deployed our edge routers, for example, maybe in some branches, and they all are connected to each other. They all are connected to, for example, each other. So when the SD-WAN, your SD-WAN controllers and like S devices, they interact to each other. Basically, when your SD-WAN network is brought up for the first time, like when your SD-WAN network boots up for the first time, or it brings up for the first time, devices are going to authenticate each other. Some sort of authentication will happen when SD-WAN bring up process actually happens. And that authentication of the devices will be handled by some certificates. Some digital certificates. So we'll talk about that anyway, but we'll talk about those self-signed certificate. How can we generate the certificate signing requests? We'll talk everything about that. Just to give you the idea, when your SD-WAN bring up process happens, actually, when the SD-WAN bring up process happens, devices, they actually authenticate each other, and they authenticate each other with the help of some certificates. Those certificates we have to install. Actually, they can be provisioned automatically, but typically if we have, suppose, for example, a certificate authority, a CA server, in that case we have to deploy, we have to actually do some configurations about the certificates. And if your connectivity is not coming up, troubleshoot the basic connectivity between the controllers so that controllers can talk to each other and controllers can talk to the routers as well. So second unit and third unit is completely going to focus on the deployment, first of controller, second of the edge router. Fine. Then we have again, from the router, once we deploy the router, we might want to run some protocols such as VRRP, Ospf, BGP, EIGRP, using CLI, using templates and everything. So here in this unit itself, we will be introduced with the templates concept. How can we do the configurations on the devices in some sort of automated fashion using some device templates and everything. So I will create a generic template for Ospf. In this Ospf template, some fields are going to be fixed, for example, the process ID, and some fields are going to be variable. And I'm going to, for example, router ID. And I am going to push this template into 500 number of devices. So the only thing that we need to enter when we push this Ospf template to those 500 number of devices, are those variable fields that you have set while creating that template. The fixed fields, the constant fields are going to remain as it is. We will see the use case of the template. We will see why we are going to use template, or what things we are going to have variable, what things we are going to have constant. All that thing we will talk about. Yes, let me know if you have any question.
Yeah, hi. So right now you are talking about the template. So
Yeah.
is that meaning do we need to know about the scripting in that script
No, 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 no,
programming
no, no,
scripting?
no, no, no. You will not be need to know any scripting. Just give me like 5 minutes. When I talk about the lab, I will show you how those look like actually. So it will give you a better idea.
Okay, sure.
Okay.
Yeah.
So just to clear, we do not require any scripting. Like we will not need to know about any like Python programming or anything like that. It is just what they have done actually. See, like whenever you deploy like any routing protocol such as OSPF, you might notice that we have to do a certain configurations again and again. For example, router OSPF one, I have to do it again and again on all the routers. So what they have done, they have just created a generic more like a GUI format of template, GUI format of things where we can actually just define that, okay, these things are fixed and these things are variable. Whatever things are variable, just set them while pushing the templates, pushing the configurations to the devices, and rest will remain same. So I will just show you in a moment. I will show you how it looks like, but no, just to confirm, no, we actually do not need at the moment any Python programming or any of this sort of knowledge. So second unit is going to focus on controller deployment. Third unit is going to focus on router deployment and all the things starting from template, basic configuration, routing protocol, underlay, overlay, everything, routing, connectivity between the branches and everything is going to be completed by these first three units. Basically, after the completion of the first three units, we will have our SD-WAN network up and running, where we can ping and trace from one location to other location, from one LAN to other LAN, one private network to other private network, over a public network such as internet, over a private network such as MPLS, and everything we will have. Once we are done with these first three units, once we have our network up and running, once we can do the ping and trace and everything, once basically we can exchange the data, now we will be good for, now we might want to actually apply some policies to change the way our SD-WAN behave. So what we might want to do here, is that we want to apply some policies. For example, hub and spoke policy in a typical DM VPN environment, for example. So that sort of thing, all the policy related things we are going to talk about in the fourth unit. Yes, let me know. You're not audible actually, just in case if you are saying something, you're not audible. Can you please check the mic settings and everything? Because I still cannot hear you. No, Arnab, at the moment, like even in as a part of our content, we will not. But yes, if you know about programming, it will be as an added advantage. So if, for example, you are good with programming, you can just create a script to push the configurations onto the devices. That is still supported. But that doesn't mean that everything is going to be from the scripting point of view only. But if you know programming, you can very easily push the configurations based on the scripts. Our SD-WAN solution based on Viptela, it allows us to actually, do all the configuration, provisioning, management related task to actually via the API calls and everything. So that is still supported. But as a part of our content at the moment, we don't require that. When we cover the DevNet certification, when we talk about DevNet, there they tell you how your, for example, those third-party automation tools such as Postman, how those interact with the SD-WAN and SDA, software-defined access. The vManage, which is the centralized management plane in the SD-WAN solution, and the DNA center, which is a centralized, controller for the SDA environment. So how that interaction of those third-party automation tools happen in the here. So we talk about that, but not here, not a part of our content. But maybe in DevNet certification you will see that. No, you are still not audible. Srinivasji, you are still not audible. You can drop your question in the chat. Maybe I can read and answer just right. So policies, policies are policies we can configure to change the way our SD-WAN fabric is going to behave. And there are two types of policy, one policy that affect the routing and one policy that affect the data. You must already know that in your traditional routing environment, you might configure some policies that filter the routes from your routing table, or maybe change the next hop while the traffic is going from one device to other device, or maybe like PBR, policy-based routing and everything. So different policies we can apply in our production environment in a traditional network. Similar type of a few policies we can apply in our SD-WAN environment as well. So policies such as end-to-end segmentation, different types of topologies such as hub and spoke, full mesh, partial mesh, and everything. Application-aware routing, where our certain application traffic will be redirected via one path, and some other application traffic will be redirected via other path based on the SLA, service level agreement, that we have defined. How can we provide a DIA, direct internet access, to the users? In my branch, for example, there are certain, this branch is a very small scale branch, maybe in some location, and there are very limited amount of users here. And what I want that for these users, internet access has to be done, like has to be provisioned locally. I don't need their traffic go to the data center, then inspect via firewall and everything. I want to perform direct internet access for the users in that particular branch. So how our SD-WAN solution is going to allow that. So that policy will come under DIA, direct internet. Apart from that, these are just general policies. We'll talk about a lot of policy. I will just show you the number of labs that we are going to do in just in a moment. So for example, here we have these different types of policies that affect our routes and policies that affect our data. And then we'll talk about security related policy. Once we have deployed our SD-WAN network, we might want to ensure some security in it as well. So application of like zone-based firewall concept, application aware enterprise firewall, intrusion prevention system, URL filtering, AMP, SSL, TLS proxy, DNS security, secure internet gateway, cloud security integration. All these we will talk about as a part of our security chapter. But remember again, this says describe, this says describes. It means that we should know the fundamental concepts of it, but we don't necessarily need to do it in practical. We will try to cover as much as we can in the practical, such as application aware routing policy, IPS, URL filtering, AMP thread grid, SSL TLS proxy. A lot of things we will be able to do, but a few things such as when we talk about umbrella integration and everything, so that thing will be limited. But we will talk a lot about these. Maybe one or two classes approximately will talk about this security and quality of service. Quality of service, how can we ensure the quality of service in our SD-WAN deployment, such as WAS concepts such as queuing, shaping, polishing, scheduling. How can we configure these different concepts in our SD-WAN deployment? We'll talk that about in security and quality of service. Maybe 1 week completely will go in these things. And by the end of this 5 units, your content will be done. At the end, you will have management and operation, day 2 operation, where we will talk about how can we manage everything from the centralized controller called vManage, such as authentication, monitoring, and reporting. How can we configure different authentication mechanism, monitoring and reporting on the vManage? This is what we are talking about, Arnab. This is what you are talking about. Describe REST API monitoring. So, SD-WAN solution still actually supports interaction with those third-party automation tool. So, for example, you are good with your Python scripting and all. So, how can that third-party tool is going to be? How that third-party automation tool will interact with our SD-WAN? We'll talk about that. I will show you a few labs as well based on the same, but I'm not going to do any scripting for this. And how can we do the image management, deploy the images? And okay, so this is the content that actually we are going to cover. Now, coming to the question, what should we know for this content to cover before we begin our content? What things we should know? Just basics. For example, you should know basics of routing. You should know basics of a little bit of security. For example, you should have the fundamental understanding, the basic understanding of IPsec. Why we use IPsec? What is IPsec? I'm not saying that you have to, go through the everything like in detail, like phase 1, phase 2, packet captures and everything. Just the basics. Just the basics that you could understand the concepts of IPsec. Cloud and everything we will talk about anyway. What is SaaS? What is infrastructure as a service? Co-location. So you actually don't need a lot of things as a prerequisite for these things. But certificates, for example, certificates we will talk about that. But you should at least know what is a CA server, what is certificate authority, what is CSR, and all. Although we will talk about that, but we are not going to go in details. That thing comes under the security. So you should have at least basic understanding of these certificates. Rest routing, for example, you should know what is BRRP. You should know what is Ospf. You should know what is BGP, EIGRP. You should have the fundamental knowledge of these protocols, because these are the things that we are going to cover as a part of our content. So at least you should know what these protocols actually. Apart from that, what is, for example, what is NAT? What is NAT? NAT you should be aware with, like you should be aware of the netting. Different types of NAT, like static NAT, dynamic NAT, these features. What is intrusion prevention system? What is URL filtering? We will talk about use cases of these things. We will not talk about in detail about like for example, AMPN thread grid. We'll talk about what AMPN thread grid does actually, but we are not going to go through the in detailed configurations and everything about any of these features. You should know, for example, what is a firewall? What is the functionality of a firewall? What is a DNS? What is a quality of service? Like what is policing? What is shaping? As per our content, we have to focus more on the configuration. Like how can we configure these things from the SD-WAN point of view? So at least the basics of it. You should know. Okay. So like for example, the iOS upgradation and everything. So at least the basics of that you should know. I still like the level of detail is very, very basic. Like it's not like you should know in very detail. And also you must not have noticed anywhere written MPLS. So I'm not saying that you go and study MPLS and everything. Just the basics, it will be enough. I would say if you have even even if you have a proper understanding of your normal CCNA, so that will be enough. Then I have disabled that unmute option, because sometimes accidentally candidates unmutes themselves and it affects the recording. So anytime, for example, you have any question, just click on that raise hand button that you have. Otherwise, you can just drop a message in the chat that I have a question, and I will just unmute you from my side. It will ensure both that the recording is proper. There's no like background noise or anything like that. And if the question or if the discussion is long, I will just pause the recording, and I will resume the recording once the question is done. So just to make the recording clean, I have removed that option from my side. Just in case if you have any question, just click on that raise hand button and I will unmute you from my side. Yes, Ajay, let me know.
What about device upgradation like vManage, vSmart? And
we will do that right here at the very end. We'll talk about that. Describe the software image management from the vManage. We will see how can we upgrade the vManage, upgrade the vSmart, upgrade the vBond, upgrade in fact all the S devices. We'll do that practically in fact at the very end of our content.
I have another one more. Few of the clients will still use MPLS when they use SD-WAN also.
That is completely fine. SD-WAN, the MPLS is going to be used just as a transport to connect their branches together. For example, branches, headquarters, data center, all together. So okay. For example, see, we'll discuss that just in a moment, but just to give you the idea, like currently we have two types of transport that we can use to connect our, for example, headquarters, branches and everything. So one of the transport that is a public transport, example such as internet. The advantage of using the internet as a transport is that it is a very cost-effective solution, and it is a very cost-effective solution, and it is going to you will be able to easily connect your headquarters branches together. But the problem with that is that it is not secured. That's why we go for that, DM VPN type of scenario. We configure a few devices as hub, like, the hub and spoke type of topology we will create. Then we will protect it with Ipsec and everything. A lot of configuration overhead will be there. The other type of transport that you can go is like private transport such as MPLS. The advantage of using a private transport such as MPLS that it is not accessible to everyone. Like only the ones who have subscribed for it, only the one who have got the access to the MPLS services from the provider, only they will get the access. It's not a public transport such as internet where anyone can join. So from that point of view, from from the accessibility point of view, you might say that MPLS is comparatively better than internet. MPLS is comparatively secured as compared to the internet. And by security, I do not mean encryption and anything. I mean like who can access and who cannot access. But still, the attacks and everything can happen in the MPLS. So we can also leverage the concepts of such as get VPN to secure whatever traffic we are sending over the MPLS network. But the point is, MPLS can be used as your primary transport. In a modern day network, companies, they might use MPLS as a primary transport, and they can use this internet DMVPN scenario as a secondary transport. They might have a high speed MPLS link connecting the branches to headquarter and all. The only reason why people were like, or the companies were more interested in the MPLS is because of that accessibility, the security related to the accessibility. There is a lot of overhead that we have to face actually in this internet type of. SD-WAN actually allows you to use any transport. I do not care what transport you are using. You can use internet, you can use MPLS, you can use 4G LTE if possible, and you can connect your different branches, for example, together, headquarter together, using all these different technologies. Okay, SD-WAN based on Viptela, for example, will automatically form an IPsec tunnel, for example, from here to here, from here to here, automatically over all the available transport that it gets. So if these two devices are connected together using internet transport, an IPsec tunnel will be formed. If these two devices are connected together with the MPLS transport, an IPsec tunnel will be formed. Automatic. That is why it doesn't matter. In SD-WAN deployment, it does not matter what transport you are using. You can use internet transport, a very cost-effective solution to connect your headquarter branches together, or a little bit comparative to that, a little bit costly solution such as MPLS. Security will be ensured by IPsec in both of the cases, even in fact in case of 4G LTE. And since I get the security based on IPsec, it doesn't matter what transport we are using. I will prefer to use a transport that is cost effective for our company rather than using a transport that is way too expensive as compared to the other one in our production environment. But again, internet is not reliable. What will you do about the reliability? For example, you have taken a connection from a broadband service provider company, let's call that X. And what if your internet connectivity goes down in one of your branches? Then how? Of course, if the connectivity goes down, your IPsec tunnel and everything will go down. Then what you will do about the reliability? It's not reliable. So I will still have the MPLS connection in my production environment. But earlier I was going for a 10 Mbps MPLS connection. Now I will go for maybe a 2 Mbps internet connection, just so we can have it as a backup. Business internet is a very popular concept nowadays. There are a lot of service providers that have started this SLA-based internet services. Like I will give you the internet services, just a normal broadband internet connection, but that will be SLA-based. So if your, for example, connectivity goes down, it will be fixed within 10 to 15 minutes or within 1 or 2 minutes. And if that doesn't, the SLA will break and you can find them as per the SLA. So that's why like companies, they might still be using MPLS as their connecting point of the devices. But again, from the cost and everything point of view, using just the broadband connection to connect all these devices will be just fine. Without any problem, it will work. So earlier, MPLS was used as the primary transport. DMVPN was used as a backup thing. Nowadays, this internet transport is being used as a primary transport, and we use MPLS as a backup. There is no concept of DMVPN here. No DMVPN, nothing. It is point-to-point IPsec full mesh. No DMVPN required. The only challenge we were facing was configuration overhead, and that is gone because this IPsec tunnel formation and everything will happen automatically. I will have multiple broadband connections, maybe multiple internet connection from 2 ISP, 2 major ISPs. I have taken internet connection, and then I have connected all of my branches to headquarter and everything. Even if one ISP goes down, I will have the connectivity with the other ISP. And remember, we get the public IPs, and all the public IPs are reachable to everyone. So even if this goes down, the reachability will still be there from here to here without any problem. So IPsec tunnel will still be there, and you can still send the traffic. a cost-effective solution. But that doesn't mean that MPLS is going to be replaced or so. A lot of people have this misconception that since SD-WAN came into the market, MPLS will be replaced by the SD-WAN, say goodbye to like MPLS network. Anyone who has studied for like, service provider track, for example, anyone who has gone through the content of CCNP or CCI routing and switching, they know the use case of this MPLS. They know that SD-WAN actually is not something that will replace the MPLS. MPLS will still be there. However, customers now have a choice. Are they going to use a costly MPLS solution to connect their branches, headquarter devices together? Or are they going to use this public transport such as internet? Because in both the cases, security is going to be provided by Ipsec. So anyway, like MPLS is not going to be completely removed, not anytime sooner, unless every service provider device is replaced with the SD-WAN router. Internally also they have like connectivity from one device to the other device using Ipsec and all. It's not going to be replaced anytime soon. That thing is still there. See, Arnab, that thing is still there. The connect, like how you get the connectivity from the service provider is completely a different thing. Fact remains the same. Once you get the IP here, these two IPs are reachable and they will automatically form an IPsec tunnel so that you can send your branch traffic from one point to other one, private to private. Okay, we'll talk more about that in detail when we talk about the users requirement of the SD-WAN. We'll talk about. Now, coming on to the lab parts to cover. Meanwhile, like till we go through the lab, what you can do, let me show you something. You can actually use Cisco D Cloud. If you search Cisco D Cloud, just like this, you search Cisco D Cloud. Okay, in the D Cloud, you can just click on that, and here you have to log in. Okay, so just open the D Cloud, and right here you log in into the Cisco D Cloud. Okay, here, just log in into the D Cloud. You will log in with your account. Let me just quickly log in. You have to have a Cisco ID. If you don't have a Cisco ID, create one. It's completely free, no problem. So once you log into your D Cloud, let me show you. Okay, so once you log into the D Cloud, okay, this is Cisco D Cloud actually. Once you log into the D Cloud, just go. This is the Cisco D Cloud where you can actually discover some different labs that they have deployed onto the cloud. Okay, so anything that they create, that they present to the customers and everything, they give a demo here, right here. Okay, just you can select any data center from here that you want, doesn't matter. Europe, Middle East, US East, US West, whatever you choose. So what I'm going to, once you select that, otherwise it will automatically select that based on your location. Click on this catalog right here. Click on this catalog. On this catalog, just do this. Click on D Cloud and click on Instant Demo right here. Okay, click on D Cloud and Instant Demo. And right here, in fact, the first thing that you see, Cisco Secure SD-WAN 20.9 with cloud integration Instant Demo preview. So here, this is the latest version of the Cisco SD-WAN solution, 20.9. Remember, it's never advised that you go for the latest versions because it might include a lot of bugs, a lot of issues that needed to be fixed. But remember that this is the latest one. So if you want old ones, you can search for the old ones as well. You can right here, you can search for the old ones. Just search with SD-WAN. Just search SD-WAN here and it will just show you different things. So for example, I search the SD-WAN here, and if I search the SD-WAN, it will show me like 20.6, 20.9, like two versions you can check a demo on. So for example, you want to check the things regarding the SD-WAN based on the version 20.6 or SD-WAN version based on 20.9, you can completely check it on the demo. So what you have to do, let's go for this 20.9. Okay, I will just click on this, scroll down, click on this view button, and side by side, you have to provide, no, that's it. Like you have to provide the username and password. Will you get the username and password? So this is an early look of the SD-WAN and everything. So I believe they have the same username and password. Related document. If I go to the related document, demo guide, I believe it will be same that they have for everyone. I will try that. Otherwise, I will check the other one. So if you scroll down, getting started, right here, demo and demo 1234. Hopefully that works. Let's see. Should work. Yes. So the password, the username password is written right here. Demo 1234. It is being recorded. So if you miss some step, you can always refer to the recordings. So this is the latest version of the SD-WAN that they actually offer. So the username password is same for all the versions, so no problem. So this is how the new GUI, new graphical user interface for the SD-WAN version 20.9 looks like. If I compare that with the SD-WAN version, that we have this, sorry. If I compare this with the version 20.6, you might find that the graphical user interface is a little bit different. Same user ID password I will use to log in here as well. So this is 20.6 right here, and this is 20.9. So you can see that 2 vBond, vSmart, and everything is there. How many number of WAN devices are there? BFD, transport, licensing, certificate status, WAN router, everything you can see. What applications are using like top traffic, so all that thing, how many number of S devices are there? 32 devices are there. Out of that, 28 you have deployed. 4 are still remaining. Latency, loss and jitter, average latency, loss and jitter onto the branches. You can check all that just from here. Just from the main dashboard, you can check. You can click on devices, for example, it will give you the information about all the devices. You can click on tunnels, for example. You click on tunnels, it will show you all the SD-WAN tunnels, secure internet gateway tunnels and all. Remember, this is just view only. So of course, you will not get access to everything, but something is better than nothing. So I would recommend you that you at least go through this graphical user interface to get yourself familiar with. Security, if you have any, like see all the security features such as firewall, a top signature hits, URL filtering. This is IPS. Signature, like this URL filtering, advanced malware protection, all those things you can check from here. This is the dashboard. This is the security dashboard. I can click on view detail and it will give me more detailed information about the same. You can see. Forget about this. We'll talk about that later. But meanwhile, until we start the lab, you can just explore this graphical user interface for the rest of the things. That cloud on ramp feature that we were talking about. These are the clouds that SD-WAN currently supports: AWS, GCP, Azure, Equinix, Megaport. These are a few cloud support that is now there in the SD-WAN. Earlier, only AWS and Azure was there. Now, then they added the GCP, Google Cloud Platform, and then now Megaport and this Equinix, they added these ones as well. So this is the dash. This is just monitoring. This is monitoring different things that you might have deployed in your environment. What about the configuration? Right here, you can do everything, configuration tool, everything. Devin, I think like there is an audio and video lag again. So you can again, you have to rejoin again. That is a problem from Zoom itself, actually. Okay. So just try to rejoin once. If that problem is still there, we will see. Okay. So for example, configuration. We can do configurations on different things. But the thing, for example, template. I went on the configuration template. And here we can define the templates that we can attach onto the devices. For example, I want to configure Ospf. Let's click on the add template button here. For what device we want to add the template? What is the device that you have in your branch where you want to attach the template? So for example, I have a CSR router, maybe for example, or I have a VH. These are the platforms that are supported. So for example, I have a VH 2000 series router in my production environment in a branch. These are the things, these are the features that are supported into that. Okay. These are all the features that you can deploy using templates. So where were we? We were talking about OSPF, for example. So see this triple P, someone, Arnab, triple P. So for example, you still have that triple P connectivity from your service provider. You can create a template for triple P, and you can leverage the same on here as well. First, let's quickly show the let's quickly see the OSPF. So for example, OSPF. I will click on that, and this is just the fields of the OSPF. As you can see, as you can tell, this is pure GUI, no CLI, nothing. This is pure GUI, graphical user interface. This is all the things. Again, like I said, I don't have the access to everything. So we can configure these things, but since I don't have access to configure the things, let me show you if any OSPF related template they have created. Okay, so they have created, in fact, a lot of OSPF template. Let me just show you how it looks like. Okay, so I'm not sure they have given me the access. Since that is only view only, so I'm not sure if no, they are not allowing us to do any changes or anything. But yeah, you get the idea that it's not going to be any CLI. It is just pure, graphical. So you can just create the templates and you can do the things regarding the same. Now in this one, it's not allowed. Let me try to show you here. This is the older version. See the difference in the older version and the new version. This is the older version 20.6 and this is the new version 20.9. So the graphical user interface differs a lot. So configuration, rest of the things are same, but the graphical interface, the graphical things differs a lot. I'm not sure they are going to allow us to do that again here or not. But all you have to do is to select the correct model, and once you do that, you can just choose. No. So they will give you the option to configure all these fields. These are just, for example, basic configuration of OSPF, redistribute, and all. So just basic things you can fill up actually. We'll do that when we deploy it in our content. At the moment, they are not letting us see, view, or change anything that OSPF template or any other template, but the point remains the same. This is just the GUI. This is just the graphical user interface. Nothing about it. So what labs we are going to cover now? These are the labs that we are going to cover as a part of our content. We'll talk about the underlay and overlay connectivity, like how we have connected the devices together, how the controllers are deployed, where the controllers are deployed, who is going to be the CA, certificate authority server, and everything. Then we manage installation and configuration in the CLI mode and in the graphical user interface mode. We want configurations in the CLI mode and installing the certificate and adding that to the vBond. Initial configurations on the vSmart and everything. So first of all, we will provide the connectivity, and then we'll talk about the controllers, like how to install the vManage controller, how to install the vBond controller, how to install the vSmart controller, how to configure the things on the vManage, vSmart, and vBond. All that we will talk about. Then the WAN edge routers, performing initial configurations on the WAN edge router, registering the VS devices onto the vManage, initial configurations on the C edge, and registering it into the vManage. Then the templates, system template, banner template, VPN template, AAA, BFD, OMP, configuring all these feature templates and attach it to the devices. Then static routing, OSPF, BGP, EIGRP via CLI and the template. We will see how can we do the configurations via CLI on the edge routers, and we will see how can we do the configurations via template onto the devices. Then additional features such as like TLOC extension. So routing and everything will be done by these 26, 27 labs. For the D cloud, you have to use your Cisco credentials. If you don't have a Cisco credential, you can always sign up for the same. It is completely free, so no problem. Then the policies, control policies such as hub and spoke policy, traffic engineering, service insertion chaining, route filtering, TLOC filtering, route leaking, VPN membership, preferred transport, application aware routing, NAT, DIA, CFLOD, quality of service, like policing, shaping, packet loss mitigation techniques, packet replication, duplication, and all. Application aware security policies, application aware firewall policies, IPS, IDS, URL filtering, AMP, limited to AMP only. We will not be able to do the thread grid. So only AMP, DNS web layer security, cloud on RAM for SaaS, cloud on RAM for infrastructure as a service. So this all is going to come under the policies. Like from here, lab number 28 to lab number approximately 45, we will be doing the complete policy lab, and up to 28 we'll be doing all the initial configurations and everything. And then day two operations, like how can we use vManage to explore variety of monitoring features, syslog, TCP dump on the VS device. How can we use that API documentation to create API calls so that we can query the vManage, software upgrades and everything. So we will be able to do all that in the day two operation. Approximately a lot of other labs are not listed here that we will do, but a lot of, I would say approximately 50 labs we are going to do as a part of our content. And this is the topology. This is a common topology that we will be using for the same. So controllers are already deployed. So this is the topology created onto a portal that you will get access of. Like you will get the access for this portal. This D cloud is for Cisco. So we are not going to do anything on Cisco. You will get the access to the portal actually. So dc.mylabs.cloud, you will get the access of this one. And here you will be able to, here we already have that topology. And here you will be able to do the labs and everything actually. I will log in with my credentials. The credential information you will get on mail from the management side. So if you have not received the credentials, you have to contact the respective person, and they will mail you the credentials. Once you get your credentials, you are going to log in with those. Once you log in, you will see like this SD-WAN 26.1. You are going to double click on it. Once you double click on it, it will open this topology. You will adjust this topology as per your requirement. So for example, I will adjust it like this. Okay, so this is the topology that we will be working on. Okay. So you will get the credentials, you will get the logins and everything here, and you will be able to do the lab on here actually. This in this portal, topology will already be there. In fact, routing and everything will already be there. I will explain you everything when we start the lab, but you only have to spend the time configuring the SD-WAN, not the other basic things such as routing and everything. So for example, IP addressing and everything is already there. You don't need to configure the IP addressing on the devices. It will take too much time. So IP addressing and everything is already there. And reachability is already there from the controllers to the controller to the vEdge and everything. So you just have to focus on the SD-WAN. Okay, so this will be our lab environment. If you guys will be interested, I will show you how can you deploy a vManage onto a ESXi. Okay. If you are interested in creating your own topology into your own, for example, home environment, you have to have enough resources. You have to have enough resources for the same. Just to give you the idea about the resource, you will get all the documents, link and everything from the front desk, from your account handler at the end of the class. So you will get all the documents and everything, like how to access the lab portal and everything. You will get a mail from your account handler, and they will explain you everything. But just in case, if you're interested in making this topology at your home, you have to have a proper resource. If you have a server, it's very easy. But if you have a laptop, desktop, you have to have enough resources for the same. For example, at least for this lab to run properly, at least a 60-core CPU you have to have in total, like 8 physical core, 8 virtual core, 8 threads. So 8-core CPU, which gives you a total of 16 cores. So it has at least a total of 16 cores have to be there in your desktop laptop. At least 64 gig RAM you have to have, because otherwise, if you have an older version of the SD-WAN, you can go for 32 gig RAM. But since the newer version of the SD-WAN supports a lot of new features, it will require more RAM. So minimum 32 gig RAM at least you have to have into your desktop laptop. Recommended 64. And some SSD is not going to matter. If you have like 100 GB, 50 GB, it will be okay. The main thing is the CPU and the RAM. You will still be able to run this lab in a 16 gig lab environment, but then again, you might have to run a few devices at some time, few devices at some other time. So it will not make any sense. So if you have a dedicated server, you can actually get you can actually create this topology onto your server, completely okay. But if you don't have a server, maybe you have a laptop desktop, then in that case, of course, you have to ensure that you have enough amount of resources to get this lab up and running. Okay, so this will be our virtualized lab. I will explain you everything about the lab at the starting of our lab content. So this was what we are going to do, what labs we are going to do, what content we are going to do. And this is the official certification guide for the SD-WAN. So for example, of course, you will get, let me show you. The official certification guide for the SD-WAN is there in the portal as well. You can download it and you can read it just in case if you want. So this is the official book for the Cisco SD-WAN. You can download it from the portal. By portal, I mean this Trainonic portal from where you have joined the classes actually. In the same portal, you will get the access to the documents and everything. So the official certification guide, it includes approximately in total 13 chapters. And in going through these 13 chapters will give you more idea about the components. All the things that we have talked about in the content are there in this official certification guide. The training PPTs that we are going to use, for example, this PPT, it will be provided to you in a hard copy format. Otherwise, they can be uploaded into the portal. If you're not here in India, for example, they can be uploaded onto the portal so that you can refer to these slides as well. So this official certification guide you can go through, and the slides you can go through for quick revision, and that will be mostly enough. So for example, you want to go for the exam. This is the exam that you are preparing for. In fact, the content that we discussed, it was from the same thing, from the same here still. So one more thing, earlier it was 1.0, so now it is 1.1. So make sure that the content is covered from the same. What we have talked about is this version 1.1 itself. It is a 90-minute exam, all the MCQs here and there. So the weightage of the chapters in this fashion. So you had to complete the exam from this point of view. That book is going to be enough. That official certification guide is going to be enough for clearing this exam. Go through the MCQs of that book, go through the content of that book, and that will be enough.
Okay.
Now, about the other things, such as, for example, you want to go for example, deployment. So you can just search SD-WAN and deployment guide. So what they have done actually, they have already created a few guides for the same. Okay, so for example, this is one of the deployment guide. You might find the other versions, but the deployment is going to remain same. So you can just download this, for example, completely free. There's no cost of it. So you can just download this deployment guide and you can just keep it handy. For example, this is the deployment guide. So apart from the official certification book, you can just go through these other books such as deployment guide and everything. So this is for the deployment. And for example, like command guide, if you want to study, so they also have a quick reference guide, command guide and everything, command reference guide. So you can download this entire thing from here, for example. Okay. Apart from that, they have a lot of guides actually. Troubleshooting guide. They also have a migration guide. For example, you want to go for migration, so they also have created some migration guide and everything. Just search for the guide, and there will something will come up actually. So high level migration in the SD-WAN, how it is done and everything. So for example, this is their migration guide, and it's not a very big document if you see. It is just like approximately 55 pages. So once you cover this, you will know the basic foundations for the deployment, whatever things are needed for the deployment, for the upgradation and everything. We will talk about some of it, but we'll not talk about everything from it. So keep these guides ready that Cisco they have actually already created, and see, design guide is also there. For example, you want to know for the design, you can go for the design guide. So how can you design your SD-WAN infrastructure, and also they have created a lot of guides actually that you can always download and refer. Official certification guide that we have it is enough for exam. Of course, you might have to refer the questions from here and there, but that will be enough. And rest design guide, deployment guide, ordering guide, cloud on RAM guide, configuration guide, everything, of course, migration guide, everything you can download completely for free from the Cisco portal itself. So that will be enough from your production environment. All this content is going to be enough. No, Imran, you will not be able to get the soft copies of the PDFs and everything actually. So as I am aware, otherwise you have to talk to the admin, of course, for the same. Whoever is your account handler, like whoever like you are in contact with, for example, Saurabh, Sugandh, or anyone else, you can have a discussion with them. But as I am aware, for example, the official certification guide is there in the PDF format. You can download it completely fine. But for example, training PPTs, they are not there in the PDF format. They are there in the portal, but you will not be able to download it. They are provided as a hard copy, but you will not be able to download it. You can, of course, you can take a screenshot of it, but you will not be able to download. The rest you can actually confirm from the admins as well. Yes, Imran.
Hello. When we will get the hard copy? I mean, they will deliver or we need to take from institute?
Again, same thing, like you have to have a discussion with the account handler, and they will tell you that either you can collect it from here, or you can actually, it will be sent to you via courier and everything. If you are here in India, if you are outside India, then they will do something regarding the same.
No, I'm in Pune, so how much they will?
Then you can collect it from here, no problem. You can collect it from here from the
Can
office.
they deliver in Pune?
Of course, they can deliver, but there might be some delivery charges and everything. Those things you have to confirm from the admin point, like. So they will tell you about the same. You use a little bit.
Lab also is there.
Lab guide and everything is there. Yes, yes. There is also the document that you get. There is also a lab guide in that document. So whatever things we are going to do, you can refer to those things from the lab guide as well. The lab guide is also there. Not from Cisco, the one that we will be covering, like this lab that we will be covering as a part of our content. There's a lab guide for this document, for this lab as well. So all the documents that you have, all the documents that you get as a hard copy format, you can collect it from. How long it is going to take to complete the content? That is also one thing. Let me just quickly show you. Although we have talked about everything, but let me just quickly show you the topics that we will be doing on day-to-day basis, just to show you. So it will give you the idea, since you have seen that there are total 6 units and it takes a lot of time to cover those units. How much time it will take for completion of our SD-WAN. So as you can see here, right here, we will start with the SD-WAN solution training, day 1. It will take approximately 24 to 25 days to cover the entire thing. In weekends, it is again 2 hours a day. So you can consider 10 to 12 weekends maximum. The content, the routing and everything is in very detail actually. So the bring up process and everything. So you can consider approximately 10 to 12 weekends maximum to complete our content. I'm good. I think like it will be approximately 2 or 3 months, 2.5 and 3 months maximum. So solution training overview, advantages, components, architecture, licensing, how can we order the devices and all, terminologies, NAT, controller deployment, S-device deployment, deploying the controller in our lab, deploying the S-devices in our lab, redundancy, high availability, and then configuration template. From here, the template part, routing part, and everything will start. Template, routing, Ospf BGP, TLOC extension, policy, 10 to 12 weekends for the same. 2 hours a day, 10 to 12 weekends, 10 to 12 timing, 10 a.m. to 12 p.m. It will take that much amount. Of course, we will try to cover it in comparatively a little bit less time, but at least you can consider this much amount of time to cover 24-25 classes max. As we have discussed in the last class, that the WAN in a modern day network has changed a lot. In earlier days, WAN or wide area network was just being used for connecting users to the internet or the branches to the data center, headquarter and all. So we were having some resources. In my data center, for example, we were having some servers in my data center. Data center devices were connected to the internet as well. And we were using WAN technologies, different types of WAN technologies. Either they could be a public transport such as internet, or they could be a private transport such as MPLS. We were using these technologies to connect the branches to the data center headquarter, or some other branches to the branches and all. The ultimate aim of connecting all these devices, all these users, branches to the data center was that so the users could get the access to the services running in the data center. In fact, the internet, even the internet was being provisioned from the data center itself. Means like if any user has to go to the internet, they will send their traffic to the data center. In the data center, there will be a lot of devices, a lot of security appliances, I must say. So firewall, IPS, IDS, and some other techniques such as URL filtering, threat grade protection, AMP cloud, DNS security, and a lot of things will be there. Maybe some load balancers and everything. So in data center, we might be having a lot of security related things, security related appliances, through which the traffic will pass first, and then it will be reachable to the internet, which ensures that since all the traffic from the user goes to the data center, and from the data center it goes to the internet was provisioned centrally via data center, or we had some sort of regional internet access, if I say, where the internet was provisioned from the data center. In that case, actually, in that case, latency was there, but at least the security was there, because in data center we had a lot of security appliances through which the data would pass, and it will almost guarantee, or it will ensure that the data is being sent from appropriate user to the appropriate destinations and all. No one is uploading unnecessary files of your company to the internet and all. So, however, users, if they need to access the internet, they will go to the data center, which will cause some latency. At least users are already connected to the WAN. They could have just accessed the internet right away from the branch itself. But no, since we do not have, or we don't want to have any dedicated security device such as firewall, UTM, or any other device on the branch. We have thousands of branches, and I cannot possibly attach, let's say, for example, I cannot possibly attach a dedicated firewall, dedicated security appliance on every branch. So I'm going to allow the internet access via data center, and in the data center, I will install all my necessary security appliances. So the internet traffic, for example, will always go via data center. That was what we were using in earlier days. Earlier, the users of the networks, like who was supposed to access the network, mostly they were users. Like they were not a lot of smart devices or IoT devices or anything like that in some older day network. In traditional network, if I must say, most of the users of the network were users. Like either they were mostly they were humans. But since the things evolved, since the technology evolved, users are not the only users of the network. Apart from the users and humans, we also have devices, and we also have things that require the internet access, or that require the access to the services running in the data center. Some IoT devices that you have at your home, maybe the smart home devices and all. So earlier, users were humans were the only users of the network, but nowadays we have humans, we have devices, we have things. We have different types of users of your network. Those users could be human, those users could be just simple devices, or those users could be things. Internet of Things specifically. All those devices are connected to the branch, and now this branch router that we have connected at the edge, which is connected to the MPLS transport, which is connected to the internet transport. This router has to send the traffic of all these different types of user to the internet, to the data center, to the maybe some services are hosted on the cloud. We already talked about that in the last class. Maybe some infrastructure is hosted on the cloud. We already talked about that in the last class. Companies are not only going for one cloud, but multi-cloud. For example, if you think that AWS cloud is better for you, for your software deployment, for your infrastructure deployment, you can opt for AWS cloud. You can go for Azure cloud. You can go for GCP, and the other cloud services. You can go for them. Maybe because of costing, maybe because of serviceability, maybe because of availability of the services onto the cloud. Maybe different reasons could be there in the company to go for not one but multiple clouds. We still need my branch devices. We still need my 1000 branches to actually connect to the data center. We still need my 1000 branches to have the internet access. But we also in modern day network, in modern day like current network, in modern day network, a lot of software, if I say application, a lot of applications, a lot of infrastructure is hosted on the cloud. So how your branch is going to deal with that, how your branch is going to deal with the multi-cloud support, how your branch is going to deal with the softwares that are hosted onto the cloud, how your branch is going to deal with the infrastructure that is hosted on the cloud. We still need these transport to connect to the data center. We still need these transport to connect to the internet. In fact, internet can be provisioned locally as well. Like some branch, I have a branch where number of users are very less, and there is no potential chance of any sort of attack or anything like that. There are only 5-10 users, maybe only one router is there. I don't want that branch traffic to go all the way to the data center, then from data center to the internet. I don't want that. Maybe for that branch, I want direct internet, DIA. Direct internet access means like the users come and their internet traffic will exit right from the branch WAN router towards the internet. It will not go to the data center, for example, processing. So different challenges are there in a modern day network nowadays. Different challenges are there. Some of these major challenges are listed here. Like in a modern day WAN, in a modern day network, how you are going to connect your branch to the data center, how you are going to connect your branch to the internet, providing some sort of direct internet access for at least some users, some devices, some things, how your branch devices, how your network is going to support the deployment of the cloud, how your network is going to connect to the softwares that are deployed on the cloud, how your network is going to connect to the infrastructure that is deployed on the cloud, and so on. There are a lot of challenges in a modern day WAN network that you might. So traditional WAN, which was just about connecting the users to the internet via data center, traditional WAN, which was more concerned with connecting the branches to the data center, where the type of traffic was like it was just the fixed amount of types of traffic that we could have. Like we were not having traffic, we were not having like devices or things as the users of your network. So the type of traffic that we had in a traditional network was very limited, if I must. However, the modern day network, modern day WAN has changed a lot. So nowadays WAN is not only about connecting the branch to the data center or connecting the branch to the internet. We might require things such as direct internet access. We might need to handle like how my branch is going to interact with the cloud services, how my branch is going to interact with the software that is hosted on the cloud and the infrastructure that is hosted on the cloud. And this modern day network, it imposes a lot of challenges as well. Some common business and IT trends in evolving WAN situation, such as applications are moving to the cloud, both private cloud and the public cloud. Like instead of deploying, let's say you have 1000 number of users, and those 1000 number of users have, let's say, for example, their own desktop, laptop, or whatever you have provided them with. And let's say all of them have to access a Microsoft Office, a very simple application for, office work. So they have to access the Microsoft Office. Now, what we have to do, we have to install this Microsoft Office on all these devices, one by one, on all those 1000 devices, maybe, for example, which is again going to be a time-consuming process. It will require subscription and everything. Not only this, but apart from this, like applications such as CRM applications, okay, and some like the different applications that could be there that you have to deploy in your onto your machines, and then you will be able to access those applications from your machine locally. But nowadays, companies have adopted this software as a service thing. What is the software as a service? Software as a service allows us to deploy that application onto the cloud, or the application, either you can deploy the application onto the cloud, your own cloud maybe. Okay. Otherwise, you can get these applications pre-deployed from cloud service providers, such as you want to go for Microsoft Office, you can go for Office 365, for example. You don't need to install like the Office at your on your device locally. You can just have the subscription of this Office 365, and you can edit the documents and do your daily work onto the cloud directly, like onto the cloud delivered this Office 365 application as well. In fact, the CRM applications or the other applications such as, for example, Dropbox, Google Drive, all these different applications. For example, you want to have storage, what you can do, you can purchase a subscription of Google Drive or the Dropbox, for example, and you can upload your devices, upload your, for example, upload your documents and everything on there. So instead of running the applications onto the local machine, nowadays, now in modern day network, applications are moving to the cloud. Now this cloud could be a public cloud such as AWS, Azure, or it could be your own private cloud that you have made. Maybe your data center, for example, on a data center, you have a data center. In that data center, you have servers. You have used some virtualization technology, and using that, you have created your own private cloud, and you are actually deploying the services there. You are deploying the applications there. So anyone who needs to access those applications, they can just access these services via that cloud which we have deployed in our own data center, or maybe on a cloud such as AWS or GCP maybe. So the point is applications nowadays are moving towards the cloud. Instead of deploying the applications onto the devices locally, I'm going to run those applications onto the cloud. It will eliminate a lot of challenges. For example, now I don't need to worry about mobility. I don't need to be like, always sit on the desk, like the same desk and do the work. I can just log in from my own personal laptop at my home. I can access that Office 365 from my home, and I can open all the documents that I have uploaded onto that. So nowadays applications are moving to the cloud, and internet. Earlier, it was being provisioned via data center. We had some sort of regional internet access where internet was provisioned via data center. So all the users, they will send their traffic to the data center. On the data center, it will be inspected by a variety of security appliances such as firewall, IPS, IDS, and all. And then it will be forwarded towards the internet. It ensures that no one is unknowingly or purposefully uploading some sensitive data to the public network internet. But nowadays, the problem is in this type of topology, in this type of scenario, the problem is how your network is going to deal with the applications that we have hosted on the cloud. How your network is going to deal with the infrastructure that we have hosted on the cloud. If this user has to access Office 365 and all of its traffic is going to the data center, from the data center it is being inspected via a variety of those security devices, and then it is going for the internet, it will include like a lot of latency. You will notice that a lot of latency will be there. A user experience will be bad for those applications. Office 365 is just a subscription based application that you can get from Microsoft, and you will be able to access all the documents and everything you can on the cloud. And just like you don't need to install an Office onto your own machine, you can just access anytime on the cloud. So they must have deployed, like Microsoft team, they must have deployed those softwares onto their own Microsoft cloud, and then they give you the access on subscription basis, just like Google Drive. Google Drive gives you the storage facilities. Office 365 gives you the facility to edit the documents and everything online onto the cloud. So I want to improve the user experience. I'm not going to send these application traffic to the data center. At least for these cloud delivered application, I want to have the direct internet access. So internet edge is now moving to the remote site. Remote site means to the branches. It's not being provisioned via data center anymore. For certain applications, maybe. For certain users, maybe. I want direct internet access onto my devices or onto my branch actually. So internet edge is nowadays moving towards the remote site. Remote site basically means the branch. Internet edge is moving towards the branch. Users are not like static. They could be roaming, and the laptops and desktops are not the only devices in modern day network to give you the access of your infrastructure. Nowadays, businesses are being done on the mobile devices. You can have a tablet, you can have a mobile device, a powerful device enough to access the resources of the company. You can connect your mobile device such as mobile phone or tab via some VPN, and you can access the resources of your company from your home maybe, or anywhere. Like for example, you are roaming somewhere, you are traveling, and you can just use your mobile phone or tablet device to access the company infrastructure. So businesses are being done on the mobile devices nowadays as well, such as mobile phone, laptops, tabs, and some other appliances. Earlier, more users were stationary, like they were fixed at a certain location. This is your desktop. You had to come here in the morning. You will sit on this desk and you will do your daily work and then you will go home. Okay, whatever work you do, you will save that work, and next day when you come, you will resume your work from there. So users were stationary at that moment, but nowadays users are a lot mobile. Like they can access their work from anywhere using those mobile devices, such as tabs, such as mobile phones, such as laptop. Bring your own device is a very popular concept in a normal day network nowadays. Like for example, at the moment, you did not get a laptop or any mobile phone or anything from the company. You can bring your own laptop if you have to the company, and you can connect that laptop to the company infrastructure, and you will be able to access the resources with that laptop also. So bring your own device is also a very popular concept in a modern day network, where users can bring their own devices, such as mobile phones, such as laptop, and they can access the resources of the company from that as well. Of course, some security policy will be applied for the same. You have to deal with the security if you have followed this bring your own device, because I can just bring I can just bring my own laptop to the company, and that laptop could be infected with some viruses, malwares, or some other vulnerabilities. And as soon as I connect that laptop to my company infrastructure, either that vulnerability will open the doors for the attackers to enter your network, or maybe the viruses and the other things could spread in your company infrastructure. So of course, you had to deal with the security in case of bring your own device type of scenario. Guest access, there are users that are going to access the company resources, and then there are some users that are there just only for the internet, or just only for some specific type of services. So for example, if you have some guest access, how you are going to provision the guest access in your company infrastructure. So guest access is also what you have to deal with in your company, in your production environment. Guest users are typically those users which do not actually need the access to the internal resources of the company. They might be there just to access the internet, or they might be there just to access certain resources of the company. And all of them, like business mobile devices, bring your own device, guest access, all of these devices and the users, they are expected to strain both corporate LAN and WAN resources. Of course, if a device is connected to your infrastructure, it is going to utilize the bandwidth. It is going to utilize the resources of your local area network. No matter if it is a mobile device, no matter if it is a laptop that a user has brought, or if it is a guest access, whatever, it is going to strain both corporate LAN and WAN. So how you are going to limit that the guest users are not allowed to access the corporate LAN infrastructure. They are just allowed to access the internet, and that their internet access will be direct. It will not even go to the data center. I do not care if they face any. I do not need to ensure any kind of security for these guest users, for example. So how you are going to deal with that? How you are going to enforce a policy in such a way that these guest users, they are allowed to access the internet, but that internet is not provisioned via data center. It is more like direct internet access, DIA. Bandwidth, high bandwidth applications. Nowadays, applications that are there, they consume a lot of bandwidth, a lot of if I say resources as well. And why is that? Why modern day applications, they consume a lot of bandwidth? If you remember in like, for example, if you're an Android user, or if you're an iPhone user, you will notice that the applications that we have in the Play Store nowadays, same Google Chrome application was very limited in size, but nowadays it is, if you see, the size of that Google Chrome application is very big. Not only the Chrome, but other applications as well. They are both big in size, and they actually consume a lot of bandwidth when you run those applications. And why is that? There is a reason for that to happen, because in a modern day network, you will notice that the content of the application is not it's not just static content. It's a rich content. It's dynamic. It's web based. We could have like a different like JPG files. We can have video running on the application. We could have text, audio, video. We could have different types of applications. Actually, we could have different type of content on the application set. And because of that, the overall size of the application, the bandwidth requirement for the application is like the requirement for that is going to be a little bit high. Since the content of the application in a modern day network is rich, dynamic, and web-based. It could include text, it could include audio, video, image files, and all. That's why it requires like a comparatively high bandwidth, high resources to run. Applications are delivered in a modern day network, not only on local machine, but the applications could be delivered in a modern day network onto the cloud. It could be your own private cloud. You have your own data center. You have used some virtualization technology, and using that, you have created your own cloud. And you are actually using that cloud to access those applications. You have deployed the applications there, and you are actually using those cloud to access that application. Software as a service is a very popular concept for application delivery nowadays. We can just contact some cloud service providers such as AWS, Azure, or we can go for example, GCP, Google Cloud Platform. We can go there and we can actually run the devices, run the applications, run the softwares based on subscription. We just need to pay for the application running onto the cloud, and then they will ensure that the application services are provided to you. You can visit the AWS Marketplace, for example, you can visit the AWS Marketplace and you can find different things as per your requirement. You can shop based on the operating system, security, networking, storage, data analytics. Different categories are there. Different types of applications, different kinds of resources you can actually run onto the cloud. Okay, you don't need to install these. You see SaaS, software as a service, right here. And if I click on that SaaS, you will see these are the applications, for example, that you can run onto the cloud. You can see F5, you can see Fortinet, example F5, yeah, this one. So these are different. How many applications? Approximately 2,193 results are there for SaaS applications, for software as a service applications that you can run onto the cloud, Palo Alto and all. So this Palo Alto network cloud delivered firewall, for example, this you can run, and this is a pay as you go, PAYG, pay as you go. You just pay for the subscription and you will be good for running this on the cloud. You can go for the pricing and everything. This is the cost of using one firewall and everything. So you just have to pay for the services, and you can run these services onto the cloud. You don't need to install a dedicated firewall onto your own premises. So SaaS, approximately 2193 number of applications, SaaS applications are there. Apart from that, other things are there as well. Infrastructure softwares that you can run. There are different infrastructure softwares that you can run onto the cloud. So SaaS, software as a service, is a very popular concept of application delivery in a modern day network. And who is going to run these applications? Who is going to consume these applications? Not only users, not only users, but mobile devices, diverse devices, different devices are going to consume these applications. They are going to access these applications. Not only user, but maybe a device wants to interact with the other device to retrieve some particular information. So that could be there. So the app consumption is done by the devices, like mobile devices, like stationary devices, users, other applications, and all and others. So different. You will notice different. Types of devices in a modern day network are going to consume those applications. So common business and IT trend, if you notice, applications are moving to the cloud. It could be a private cloud or a public cloud. Internet is moving towards the remote side. Business is being done nowadays not only on the stationary devices, but the mobile devices, such as internet, such as mobile phones, such as tab. Bring your own device is a very popular concept, where the users are supposed to bring their own laptop, their own maybe mobile device, tab, and they can be connected to the company infrastructure to access the resources. Guest access, for example, if someone comes and they are basically just there to access the internet services. So how we are going to separate them? How we are going to separate their access from the corporate users access, for example? And both, like all these mobile devices, bring your own device, guest access, it is going to consume like both corporate LAN and WAN infrastructure. So how you are going to deal with that? How you are going to limit that the guest users, they do not talk to the corporate users, that the guest users do not consume more than allowed bandwidth, so that the corporate users, they are not affected with that. The applications that we run in a modern day network, they consume high bandwidth. Why? Because actually the content of the application is rich, dynamic, and web-based. The delivery of the application is not only done locally on the device, but onto the cloud, in a virtualized environment, or in a, for example, a software as a service. We can contact these cloud service providers, and they will, such as AWS, Azure, GCP, and others, and they will deliver the applications onto the cloud. Application is consumed not only by mobile devices, but by some other devices as well, some diverse devices as well. Mobile phones, tab, desktop computers, servers, and all. So how your modern day WAN is going to deal with these challenges that you are facing. These are some common business and IT trends in an evolving WAN situation. And then these are some critical, let's say you are running some very business critical application in your production environment. An application that that if it is inaccessible for a certain amount of time, for example, maybe 2 minutes maximum, it will cause a lot of damages in terms of money. Like you will lose a lot of money if that application is not running for, let's say, only 2 minutes. Maybe you are running or you are giving support to some banking sector, some banks, maybe, for example. So let's say you are running some business critical application. If you're running some business critical application in your production environment, so the SLA, the service level agreement, has to meet for those business critical applications. Like how you are going to deal with the single link failure. For example, you are running the applications on some servers, and those servers were connected with the rest of the network with multiple applications, or the services were accessible via multiple applications. How you are going to deal if one of the link goes down? How you are going to deal if one of the link goes down, or how you are going to deal with like all the links goes down? If one link goes down, or if all the links go down, then how you are going to deal with that? Single link failure, how you are going to deal with the single link failure? How you are going to deal with all link failure? And what will happen if customer premises equipment? What will happen if the CPE device actually fails to perform, fails to work? What, like if the application is delivered, is delivered onto the cloud, and the users are facing the latency, accessing those applications. Someone is saying that their Office 365 is not working properly. So how you are going to deal with that? Yes or no? How you are going to deal with the single link failure? How you are going to deal with, like, if all the links go down, what will happen? How you are going to deal with the customer premises equipment failing onto the customer side? The application is deployed. Onto the cloud, and what is happening that the users are reporting that they are facing a lot of latency accessing in that particular application. For example, you have deployed the Office 365 onto the cloud, and someone is saying that they are facing a lot of latency. Their Office 365 application is lagging a lot, and user experience is not very good in that case. How you are going to like if you have deployed a certain application in your production environment, how you are going to make a topology based on the application? How you are going to make a topology around that particular application so that the user experience could be improved? Maybe I want to prioritize that application traffic as compared to the other application traffic, or as compared to the other data traffic, so that particular application traffic is sent in a better way as compared to the others. It will improve the user experience. What if the MTU in some path? What if the MTU in some path changes? How the fragmentation, segmentation, and all that thing will be handled for that particular business critical application? What if the bandwidth is oversubscribed? Like you purchase the bandwidth of 10 Mbps from your service provider, but a lot of users are accessing that particular application, and because of that, the bandwidth got oversubscribed, and you are not having enough bandwidth to accommodate all the users. Okay, what about like if you are facing any some sort of brownout issue? What is this brownout means? Like a performance issue, and like the network quality. What is brownout? What is this brownout? It means that unintentional drops in your network quality. Like what happened? Like your network was behaving properly, but due to some reason, I'm not sure why, but due to some reason, your network actually the quality of your network actually got dropped by some point. So how you are going to deal with these different SLAs regarding those critical applications? In this case, we are going to maybe we will create some sort of application aware routing, or maybe we are going to create topologies based around my applications and all. So maybe we are going to connect our branches, home offices, the customer locations with multiple transports such as internet templates, 4G LTE, so that even if one path goes down, even if one path goes down, at least the other path is available. So how you are going to deal with how you are going to deal with this different challenges that you face here. Resilient network design with more than one WAN type is good if critical site. Yeah, that is fine. So if you have, like, for example, more than one, if you could manage to have more than one WAN connection for one site, so that all the devices are interconnected to each other, and if one transport goes down, at least the other transport is available to take over, then it's fine. Yes or no? Question is, what is the difference between Zscaler and SD-WAN? Okay, you got the answer, Arnab. Zscaler is a SaaS, software as a service for security services, and SD-WAN is technology to manage the WAN. It is Zscaler is Zscaler is mostly a cloud security company, actually, and it helps. It offers that the companies, they move their data to the cloud, and it allows the users to work remotely while ensuring the security. And the SD-WAN, something that we use, is a technology that we use to, in fact, manage all the managed devices from a centralized point. So if you have different applications, if you have some business critical applications running in your infrastructure, how you are going to deal with all these challenges? Single link failure, all link failure. If the application is delivered onto the cloud, how you are going to address the latency issue? How you are going to make a topology around your application so that the application traffic is prioritized as compared to the other traffic? How you are going to create an application aware topology where a certain application traffic is passed via a path where maybe latency, loss, and jitter is comparatively low than the other path? How can we create a topology in such a way? How your application is going to deal with the MTU changes? How your application is going to deal when the customer premises equipment fails? How the application is going to deal with the bandwidth over subscription? And what if the network quality degrades suddenly due to some reason? How your application is going to deal with all those challenges you might face in a business critical application that you have deployed in your production. Yes, these challenges were addressed by we'll talk about these solutions of these challenges, but all the challenges were addressed by the Cisco SD-WAN solution. Not only Cisco, but the other SD-WAN solution as well. But since this is a Cisco SD-WAN solution training, we'll talk about how Cisco has addressed all these challenges. So as per the Cisco SD-WAN solution, first of all, it is transport independent WAN fabric. What do we mean by this? We mean that you can have your devices deployed onto different locations, such as branches or headquarter, maybe data center, cloud, doesn't matter. It doesn't matter how you connect all these devices, what transport you are going to connect, what transport you are going to use to connect these devices. Transport independent WAN fabric means that we can use as simple as a broadband connection to connect my devices at different location. I can use 4G LTE. I can use business VPNs. We can use technologies such as like MPLS, business internet. It does not matter what type of transport you are using, connection between the devices of your different locations. Cisco SD-WAN solution is completely transport independent. By transport independent, I mean you can connect the devices with whichever transport you want. You can have as simple as a broadband connection to lease line, MPLS, 4G LTE, whatever you want. At the end, that the thing that will matter is the reachability. You have the reachability from this device to this device, that's it. You have the reachability from this device to this device, that's it. No matter how or which transport you have used, what WAN transport you have used for the reachability. Transport independent WAN fabric. Second, endpoint flexibility means the end devices doesn't necessarily need to be a hardware device. Like the routers that we are talking about, we can purchase a hardware router, but that doesn't need to, like, it doesn't mean that we have to purchase a hardware router only. Cisco SD-WAN solution gives you the flexibility that you can deploy these as devices in a virtualized environment such as ESXi. Like you can download the images. If you think about it, even the operating system such as iOS that we talk about, iOS Internet Working Operating System that Cisco has, iOS runs on a particular hardware, such as if you have a router, so you have to purchase a router, and that you will install a operating system, and then you will get all the functionalities of that particular router. So you have to purchase a hardware, then you will install the operating system in it, more like the software, and you will get all the functionality. The point is, Cisco SD-WAN solution allows you to deploy those routers, those endpoints as any either hardware, or they can also be deployed as software in a virtualized environment such as ESXi, or in fact they could be delivered on cloud. So we can have a dedicated hardware such as V-Edge router or C-Edge router hardware platforms, or we can just download the images of it from Cisco website and we can deploy it in some virtualized environment such as ESXi. Both will work. We have the flexibility when it comes to deploy these devices, these routers in our production environment. We don't necessarily need to purchase. We don't necessarily need to purchase a dedicated router for that. We can just download the image and we can deploy it on the virtualized environment such as ESXi. We'll see that in a moment. The SD-WAN solution can be completely cloud delivered. There are two important components of the Cisco SD-WAN solution. One is the controller and second one is the edge device. There are two important concepts. There are two important components, if I say, when it comes to Cisco SD-WAN solution. One is called the controller, and second one is called the edge devices. There are three controllers that you will see. We'll talk about them later on. vManage, vSmart, and vBond. There are three controllers that you see. And edge devices, we have something called vEdge devices and the CS device. Edge devices that you must have guessed, like edge devices are the routers that we deploy at the edge or endpoint at the edge of our network, connecting us to the other branches, connecting us to the internet. They could be either Viptela operating system based edge devices or iOS XE SD-WAN based edge devices. Both could be. Controllers are the points from where we can control almost everything of those edge devices from a centralized point. Both of these solutions, like if you want to deploy the controllers, you can deploy the controllers on your premises, or you can deploy the controllers onto the cloud. Both will work fine. Cisco SD-WAN solution can be actually completely cloud delivered. Cisco SD-WAN solution can be completely cloud delivered. You can deploy these controllers, for example, onto the public cloud, such as AWS, Azure, or you can actually deploy these controllers on your premises, on premises. Both will work fine. You can contact the providers. If you can purchase the SD-WAN solution directly from Cisco, or you can go to some cloud service providers and you can actually get the services from there. What is Msx? I didn't get it. We did not talk about Msx or NSO. So cloud delivered. The SD-WAN solution can be completely cloud delivered. The SD-WAN solution that we have here, it can be completely cloud delivered, or it can be delivered on the premises. Completely up to you. If you have if you have chosen the option to deploy the controllers onto the cloud, they could be deployed in a single tenant environment or a multi-tenant environment. What is this single tenant environment? Single tenant environment. Let's say you go to some, manage the service provider, MSP, manage the service provider. You went to the managed service provider. You did not go directly to Cisco because if you go to Cisco as a company, they will provide you with the SD-WAN solution, but the charges, the costing might be a little bit high actually. So the point is, you went to these manage the service provider and you ask them that you want to deploy the Cisco SD-WAN solution, you want to get the Cisco SD-WAN solution. So these managed service provider, on the behalf of the customers, they contact Cisco and they get the solution from Cisco and they give it to the customer. But it will be a little bit cost-effective solution. This will be more like a cost-effective solution. So when you go to these managed service provider, they will ask you, do you want to deploy the controller in a single tenant environment, or you want to deploy the controller in a multi-tenant environment? What do we mean by that? What do we mean by single tenant environment and multi-tenant environment? Single tenant environment means that for your organization, a dedicated set of vManage, vSmart, and vBond will run in a cloud. Like the resource is not going to be shared with anyone else. There will be a dedicated set of resource available only and only for you. Of course, it is going to cost you a lot, comparatively more. So single tenant environment, if you say, no, I don't want to share my resources with anyone, I want to have a single tenant environment. So in that case means like one set of resource, dedicated set of resource will be there, like one dedicated vManage, one dedicated vSmart, one dedicated vBond, or maybe more than one if you want, will be there only and only for you. Those resources will not be shared with anyone else. Single tenant deployment of the controller. Single tenant means like you are the only tenant, you are the only owner, for example, of those resources. Of course, it is going to cost you a little bit more as compared to the multi-tenant deployment. What do we mean by multi-tenant deployment? Multi-tenant deployment means, for example, these two customers, they say, okay, we don't really care actually. I do not have that much amount of devices to actually manage anyway. So we can go for the multi-tenant deployment. So what happens in the multi-tenant deployment, that one vManage and one vBond will be responsible to manage multiple tenants, multiple tenant devices. Like it will be responsible to manage both the tenants like B and C. Means there will be one resource of the vManage managing the devices of organization B and organization C. There will be one set of resources of, there will be one vBond which is responsible to manage the devices of both B and C. vSmart is not shared actually, vSmart is dedicated. So it will be separate for every customer. For both the customer, it will be separated, but the vManage and vBond resources can be shared by multiple tenants at the same time. Multi-tenant deployment allows you to actually use the same set of resources of vManage. Of course, there is going to be some sort of role-based access control where the managed service provider, where the MSPs, they are going to, of course, they are not going to give the access of customer C to customer B or customer B to customer C. They will have that separation. But the single set of resource will be there, single vManage, single vBond resource will be there for multiple tenants, for multiple customers. And since Cisco, they in this slide, they have not talked about MSP. They have just talked about Cisco's SD-WAN deployment. We can go for the MSPs as well. It could be single tenant, it could be multi-tenant, completely up to you. Control, management, and orchestration with the vManage, vAnalytics, and Msx NSO. This, vManage, Viptela Manage, vManage, vAnalytics, these are the tools that can be used to control and manage the deployment of the controllers onto the cloud. And this, this Msx that they are talking about, Msx or NSO that they are talking about, this is Msx stands for Managed Service Accelerator. It is, it is a platform that enables Cisco or the other vendors to quickly deliver cloud-based services for the enterprise network. They have a dedicated you can say that these are some software platforms. This MSX is Cisco Managed Service Accelerator. This basically this is more like a software that they have created. This is more like a it is a service that they have created, which allows them to quickly provide the SDN solution for the customer. And same goes for the other one as well. Like we can go for vManage, we can go for vAnalytics to get all the analytical information of your enterprise network. This MSX and NSO is something that they have created, which is responsible to orchestrate the control and management of the controllers onto the cloud. So this MSX and NSO actually it is more like a tool. It is more like a software that Cisco has created so that they can deploy, they can provide the services in faster and more easy way for the customers. Actually, MSX and NSO is the product itself. Like you can just search Cisco MSX and NSO, and you will get the GUI of that, and you will come to know that it's basically more like a platform that allows them to quickly deliver the cloud delivered services to the customers. Like for example, you go to it is pure like automated, in a pure automated fashion. They allow you to, for example, a customer comes with the requirement that they require one vManage, one vSmart, one vBond. They can use that MSX and NSO for automation and programming, and they will provide you the access to. They will deploy the controllers onto the cloud. They will give you the access to those controllers deployed onto the cloud in a very easy. So it's more like a product that they have. We don't get the access to that as a part of our solution. We don't get access to that. We only get the access of vManage, vSmart, and vBound. We don't even get the access to the vAnalytics. We don't get the access for like to MSX and NSO. vAnalytics is a cloud delivered analytics engine actually. So it is an optional solution element for the SD-WAN. If you want, you can go for this vAnalytics as well, but you have to pay for that. Not pay actually, not pay actually, but you have to give your permissions to Cisco to collect the statistical analysis of your entire network. We'll talk about that dedicatedly later on. But vAnalytics is an optional component of the SD-WAN solution that you can opt for. It is more like an opt. It is available as an opt-in basis. Like if you want, you can have this, but if you don't want, no need to have this. It is just this vAnalytics is just going to give you the analytical information of your entire infrastructure in a way that it gives you the information about the applications running into your infrastructure, network of your entire infrastructure, which application is facing latency issue and all. It is just the graphical devices. It is just again graphical platform where you can analyze your entire infrastructure from a centralized point. However, you have to give the permission to Cisco to collect the statistical data in this case. Yes, one single vManage can accommodate approximately 2,000 number of devices. And for more than that, you have to actually go for more than one vManage. So this solution is completely cloud delivered. Transport independent. We can have either hardware or a software as a endpoint, and it could be completely cloud delivered. You can deploy it on your premises as well if you want, but it could be completely cloud delivered so that you don't need to worry about the resources, power supply, redundancy, high availability, nothing. You don't need to worry about that. Again, same thing, same question. Anyone facing any issue in the audio? Just confirm once. Is the audio correct? Is the audio okay? Just confirm once quickly. Amandeep, anyone, anytime they face any problem in the audio, just rejoin. Okay, it might be issue from the Zoom. Just rejoin. We see these are three different things, but if you want, you can deploy it on a single virtualized environment. Like on a single server, you can deploy all of them. But again, that might not be a very good idea, because if that single box, if that single server, for example, fails, everything will go down. So these are three different things, but you have the option to deploy all of them in a single virtualized environment, single server, for example, single ESXi server, for example. For the infrastructure that we have hosted onto the cloud, my SD-WAN devices can act as a gateway as well. The SD-WAN router that we have deployed on the cloud can act as the gateway for some co-location center. What is this co-location center? Co-location centers are shared data centers that we have across the world, where you can just deploy your device without the headache, without worrying about managing the data center infrastructure. Like, for example, I had my data center. What I'm going to do, I'm going to rent it out. Like that. SD-WAN devices or SD-WAN router that we have, let it be like the vEdge router or the cEdge router. They can act as the gateway for the devices that you have deployed in a shared data center or in a co-location center, for example. We'll talk more about that in the cloud on-ramp for co-location feature. The cloud on-ramp for co-location feature allows our SD-WAN devices to act as the gateway for the infrastructure that we have hosted onto the co-location centers. Co-location centers are, again, just to tell you, co-location centers are the shared data center that we have, and those shared data centers are owned by someone else. We just deploy our devices there. We just deploy our maybe firewall or some other devices there. Now, SaaS, software as a service, for example. Software as a service, for example, is a very popular concept in modern day network. Like we are deploying, we already talked about that. Secure Now, Office 365, Salesforce, these are different types of services that we can, different types of softwares that we can run onto the cloud. And we can extend the capability of the SD-WAN. We can extend the capability of Cisco SD-WAN to the cloud with the help of cloud on-ramp for a software as a service feature. There is a feature called cloud on-ramp for software as a service. This feature allows us to improve the user experience for cloud delivered applications such as Office 365, Salesforce, and everything. In fact, if you have deployed your infrastructure on some public cloud such as AWS or Azure, cloud on-ramp for infrastructure as a service feature allows us to extend the capabilities of the SD-WAN or extend our SD-WAN solution to the infrastructure that we have hosted onto the cloud. So cloud on-ramp is a feature. Cloud on-ramp is a feature. Cloud on-ramp for software as a service, cloud on-ramp for infrastructure as a service, and cloud on-ramp for co-location, colo. Cloud on-ramp for software as a service allows us to improve the user experience for cloud delivered applications such as Office 365, Salesforce, and the other. Cloud on-ramp for infrastructure as a service feature allows us to extend the SD-WAN capabilities to the infrastructure that is hosted onto the cloud. For example, you might be running some cloud delivered firewalls or cloud delivered branch, cloud delivered data center, for example, and you want to extend the capability. You must be running some resources onto the cloud. Maybe some router, some switches, some firewall, some virtualized environment. You are running something on the cloud and you want to manage those devices from your SD-WAN. You want to extend the capabilities of the SD-WAN to that infrastructure that you have hosted onto the cloud. For that, we have the feature called cloud on-ramp for infrastructure as a service. And cloud on-ramp for co-location allows us to extend our, it allows us to extend our SD-WAN capabilities to the co-location centers, shared data center, if I must say. So Cisco SD-WAN solution addresses all these challenges. Like, for example, we don't need to worry about the transport. We can have a transport such as internet, MPLS, 4G LTE, whatever. We can have any of these type of transport. As long as the connectivity is there, everything is okay. And remember, the traffic will pass from one branch to the other branch securely. As soon as one device comes to know about the other device, they automatically form an Ipsec tunnel between them. Automatically. And my traffic from one device to other device will be shared using that particular secured Ipsec tunnel without any problem. So I don't really care if I'm connected, if I have provided my reachability between these two devices via internet, via 4G LTE, via whatever. I do not actually care. Because I could use a costly MPLS solution. I could use a costly MPLS solution, or I can actually use just a broadband connection. As long as the reachability is there, my traffic will be delivered securely from one side to the other side with the help of the Ipsec. And the best thing about this is that we don't even have to do any configurations of the Ipsec. Endpoints could be flexibly deployed hardware, or they could be deployed as a virtual devices. Like we can just download the images from the website and you can just directly deploy it in a virtualized environment such as ESXi, completely fine. The solution can be completely cloud delivered, managed, orchestrated by Cisco, or you can go for those managed service provider. On the behalf of you, they will get the solution from the Cisco and they will give it to you. You can do that. Or maybe you can be some managed service provider and you can take the requests from the customer and you will contact Cisco for the services, and then you can provide the services to the customer. And my SD-WAN can act as the cloud on-ramp feature allows my SD-WAN to act as the gateway for co-location center, for the infrastructure as a service, and it improves it helps in improving the user experience for the softwares that are deployed onto these things. How they are there? Actually, is there any hardware for the same? We have talked about there are three things. There are two things actually. One is controller, one is S device. Okay, S devices could be VS device or the CS device. Are those hardware? Are those softwares? What exactly are these? We know that vManage is a controller. We know that vSmart is a controller. We know that vBond is a controller. We know that we have the VS devices and the CS devices. But the question is, are they hardware? Are they software? Are they both? What exactly are those? So what you can do, you can visit software.cisco.com. Okay. And software.cisco.com, you visit once. You just log in with your credential. So let me just quickly log in with my credential. Just give me a second. I will just log in. Once you have logged in, just scroll down and go to this downloads and upgrade page. Click on this access downloads. Okay. Here you can search, for example, here you can search for SD-WAN. So I have already done that. So I will just click on this SD-WAN. And or let me just go back and just search the SD-WAN. Right here. So if you see, if I search for this SD-WAN solution right here, if I search for the SD-WAN, I have the SD-WAN solution. If I click on that, it will tell me that these are just softwares. vManage software, vSmart software, vBond software. vBond and vEdge share the same image actually. So vEdge and vBond both share the same image. vBond more like runs as a service onto the VS devices. You can say that. Okay. So the point is, if you want to have a vBond in your infrastructure, the image that you have to download is going to be this one. There's only one command that you have to execute. Running that command will convert, or running that command will enable the vBond services onto that particular VS device. That VS device will start acting as the vBond orchestrator. One more thing, vManage is called NMS. I always called vManage as NMS. I call vSmart as controller. I call vBond as orchestrator. Okay. Although every of them comes under the controller, like these are SD-WAN controller, vManage is a controller, vSmart is a controller, vBond is a controller. But vManage is more like a network management station from where we can do all the management level of task. All the management plane functionality has been moved to a controller, a centralized controller called vManage. All the control plane functionality, like learning the routes, advertising the routes, applying the route filtering policy and everything, has been moved to a centralized controller called vSmart. So I call vSmart as a controller. And vBond is something called an orchestrator. It is responsible to orchestrate the entire SD-WAN solution. It is responsible to authenticate all the devices when they come online for the first time. So when the SD-WAN bring up process happens, it is the vBond orchestrator that facilitates the authentication between the devices and allows the devices to join the SD-WAN solution or SD-WAN network that you have created. Okay, so I always called vManage as NMS. I always called vSmart as controller, and I always called vBond as orchestrator. However, every one of them will come as the controller. So vEdge, we have here the vEdge router that we have here. I just have to use one command, and that command will actually enable those vBond services onto that device. vManage again is a software, vSmart is again is a software. And if I click on this vManage software, I can see the latest release is 20.9.1. Okay. The latest release is 20.9.1. It is approximately 2.5 GB. Okay. You can check for the release notes. You can check for what VS devices are compatible with this. You can check all the release notes for the controllers and everything. And once you are satisfied with the features that are available in this, you also have to see what bugs are there, what problems are there. They will list you that. Recommended release is still 20.3.5. Recommended release from Cisco is 20.3.5 based on the quality, stability, and longevity. But the latest version, this ED stands for early deployment. So more recently, like this has been launched. So you can download an OA file, or you can download an OA file for VMware, and you can download a QCOW for KVM, or if you want to deploy it on the cloud, you can deploy it on the Azure cloud, and you can download this one. So this you can download and completely deploy in a virtualized environment. There is no box for this. There is no hardware for this. You have to have a server, and you can deploy it on the server. Just like you deploy a typical OA file in a VMware, similar process. Same goes for the vSmart as well. It is just a software that you have to download approximately only and only if you see it is 175 MB. It is not that big. You can download this OA file, or if you have KVM, Linux-based kernel virtual machine, then you can have this QCOW, and then you can deploy it onto the cloud as well. Cisco SD-WAN Cloud on Ramp is a service which integrates Cisco SD-WAN solution with AWS, Azure, or any other private cloud services. Yes, you can say that. Based on what type of service you have, you got from those cloud service providers such as AWS or Azure. It could be called as cloud on ramp for software as a service or infrastructure as a service. vBond and the VH images should be same. Not should be, actually, it is same. It is same. Like there is no dedicated image for vBond. If you want to have a vBond, you have to download this image. This VH cloud image you will download. You will deploy it in a VMware or KVM, wherever, and you just need to run one command. The command that that starts with this vBond, IP, and local keyword. So that command you have to just write down, and it will start acting as the vBond instead of running as the VH actually. So the images for both images for like these are just softwares that you can download, and also there are hardwares. It's not like this is only software. For example, you go for the VH router. In the VH router, we have different models of the VH router. Okay. So we have, for example, VH 100B, 100M, 1000, 2000, 5000, different models of the edge routers are also there. We'll talk about that later on, the hardware series, but there are dedicated models for the routers as well. And if you have a Cisco iOS device, you can run the iOS XE SD-WAN on ASR 1000 series router, CSR, ISR 1000, and ISR 4000. You can run iOS XE SD-WAN on these platforms. You can run iOS XE on these platforms. Okay, you can just, for example, in your infrastructure, you already have an ASR 1000 series device. So you can just download the iOS XE software. You can upgrade your existing operating system to iOS XE SD-WAN, and you will be good to integrate that particular device, or you will be good to control that particular device from the centralized point. So as you can see that these are mostly like these are just softwares. You can download these. You can download these images from the website, and you can run it in a virtualized environment. You can run it in a virtualized environment such as ESXi, KVM, or even onto the cloud. Fine. Same thing again. True enterprise SD-WAN, same thing again. Transport independent WAN fabric. We can have as simple as broadband, MPLS, or cellular transport, where we don't need to do any configurations. And I do not, of course, I do not trust the broadband connection or cellular connection because it is a public network and anyone can join the public network. So transport independent WAN fabric, for example, transport independent WAN fabric we can have. We can run different services such as routing, security, segmentation, quality of service, multicast, service insertion, survivability, different services we can run. Different applications we can run. Like, for example, we can steer our application traffic based on SLA, traffic engineering, for segment topology, different applications we can run to accommodate different facilities in my. We can do all the operations, we can do all the monitoring, we can analyze the entire thing from a centralized point. We don't need to have, we actually do not need any specific monitoring tool, but if you have that, it's a very good, it's very good actually. So Cisco SD-WAN provides all these facilities to you. It is completely software defined. It is completely software defined. It's true separation for control, data, and management. What do we mean by that? The question is, if we did not opt for the vAnalytics, do we still have some monitoring? Yes, you have some monitoring features. You still have some monitoring capabilities on the vManage inbuilt, but it will not be that, like, it will not give you as much as information as a dedicated vAnalytics. But yes, you still have that. The graphical user interface will show you a lot of things. And using those things, you can actually, monitor a lot of things, but it will not be as good as that dedicated vAnalytics. Software defined, true separation of control, data, and management. What do we mean by that? In traditional network, let's say, for example, in a traditional network, we have created, for example, this topology, and we have to, this is a network. Let's call that network as 10.1.1.0 network. And here we have a network, let's call that 10.1.2.0 network. Okay. Now I want to ping from this device to this device. So what we have to do, for every device, all of these devices have their own, control plane, data plane, and management plane. Control plane, data plane, management plane. Basically, all these devices have their own set of control plane, management plane, and data plane. What do we mean by this? We mean that if I want to manage this particular device, or we want to manage all these devices, what we actually have to do, maybe, for example, we are going to take a console cable. First, I'm going to connect to the console port of that device. Then I will do all the configuration. Then I will connect that console to the second device. Then I will do all that configuration. Then I will do the configurations on the rest of the devices, just like that. So the point is, since all the devices have their own set of control plane, data plane, and management plane, let's say, for example, we have to manage the devices. Management has to be done on box by box basis. We have to do the management. If you have to do the management, the management has to be done on box by box basis. Route, we want to have the routes available everywhere. We want to have this route available everywhere. So I have to run some protocol for that. I will run the protocol such as maybe EIGRP, maybe Ospf. On all these routers, I'm going to run the protocols. On this router, I have to run the protocol Ospf. On this router, I will run the protocol Ospf. On this router, I will run the protocol Ospf. On this router, I will run the protocol Ospf. Since everyone has its own set of control plane, I have to do the configurations of the protocol on all the devices, and then they will form the Ospf neighborship, exchange the information, and then you will be able to ping. It's not like there is a centralized protocol, like I can run Ospf just on one device and everything, or there is just one routing table that everyone can consult and just do their forwarding based on that. There is nothing like that. And also, since everyone has their own set of data plane, means when the packet arrives, I will forward that data towards the other device by looking at my own routing table. There is no centralized data plane functionality or capability based on the same. So in earlier days, we had this, distributed architecture. Distributed architecture means all the devices have their own set of control plane, data plane, and management plane functionality. which means that all the devices, if I have to do the management of the device, the management plane is concerned with the device management. How you are managing the device. Are you doing telnet? Are you doing SSH? Are you using console port? Are you using like remote access, whatever? Management plane of the device is concerned with the device management. And since all the devices have their own management plane, means that the management has to be done on box by box basis. Means that I do not have any centralized point from where we can do all the device management. Control plane, since everyone has its own set of control plane, means that I have to run the protocol. Control plane is responsible, for example, to handle the control plane protocols such as Ospf. Once we configure Ospf on one router, it will start sending the Ospf messages to the other router, and then they will once they have exchanged the data, once they have exchanged the messages, they will form the neighborship, exchange the routes and everything. So that is all control plane functionality. Populate the routing table, create the routing table, create the ARP cache, run the protocols such as Ospf, IGRP, BGP, STP and everything, for example. Since everyone has its own set of control plane, I have to run the protocols on all the devices so that they could form the neighborship and everything. And the data plane. And the data plane, when you talk about the data plane is concerned with the data forwarding. The actual data forwarding actually happens with the data plane. When we specifically talk about the data plane, which is concerned with the data forwarding, data arrives onto the router. It is data plane that will perform encapsulation, decapsulation on the data and forward it respectively. In earlier days, since control plane, data plane, and management plane was distributed. In earlier days, since all these things were distributed, you will notice that in this case, I have to do the management. I have to ensure the control plane functionality, the data plane functionality on all the devices indivisibly. I have to do that indivisibly. What they have done, since they wanted a centralized management, so what they have done actually, they took out the management plane functionality from the device. And they created a controller out of that. They took out the control plane functionality of the device and they created a controller out of that. And the data plane is the only plane that remains on the device itself. For example, the routers nowadays are just data plane devices. In the SD-WAN, the router that we use, in the SD-WAN, the routers that we use, the VH router or the CH router, these are called just the data plane devices. The management functionality, the management plane functionality of the device is moved to a controller called vManage. The control plane functionality of the device is moved to a controller called vSmart. And the data plane functionality remained on the devices, on the CS devices or the VS devices. Remember, this does not mean, that on the VH router, for example, or on the CH router, for example, this does not mean that we are not going to have the local management or we are not going to have a local control plane functionality. When we do the lab, I will show you, that even if that VH router or the CH router is not even connected to any of the controller, it can still form the neighborship with the local, with a non-SD-WAN router directly, and it will still be able to forward the data. It is just a functionality. It is just a concept. This SD-WAN allows us to actually centralize the management plane functionality and the control plane functionality with the help of a controller. That does not mean that we cannot have the management plane locally onto the device, or we cannot do the device management locally, or we cannot forward the data unless it is connected to the controllers and all. It's not like that. When we do the lab, it will be more clear, but it's not actually like that. We can still use the we can still have the management of the device locally. We can still see that the protocols can run onto that particular VH router or the CH router, even if they are not even connected to the controller. That is completely fine. But what they have done, the point is to ensure that the things are centralized, centrally managed. They have removed, I would not say removed, they have centralized the management plane, and they have centralized the control plane functionality with the help of a controller. And that controller is what they are referring to as vManage and the vSmart. With the help of SD-WAN, we get a true separation between the control plane, data plane, and management plane of the device. Yes, let me know.
So, sir, does it mean that the VH and CH is having the data plane traffic? They are making the decision on the interface level how the data traffic should be moved, correct? But management plane is also there, like when we configure them through the CLI.
Yes, we can do that.
Yes, we can do that.
No,
We can put one.
Right?
We can put one in.
Yeah, we can put one interface in. We can put one interface in one in management, and we can do out of band management just via CLI. No need to go for a centralized management in that case.
Okay, I don't understand this cloud point when you define this.
Which cloud?
Which cloud?
These like the VH and CS can be cloud hosted, or like it is physically hosted on the sites, right? So if it is cloud hosted, how does it will work? I don't understand.
There is a specific uses of that. There is a specific condition when you are going to deploy the VS devices or CS devices onto the cloud. For example, when we talk about cloud on-ramp for infrastructure as a service, where we said that the cloud delivered infrastructure can be connected with the SD-WAN, how you are going to connect a cloud delivered firewall with your SD-WAN. So we are going to deploy two either VH or CS devices onto the cloud, and we are going to connect it with the firewall, and we will get the access of that VS device or the CS device from our vManage. So there is a specific use case of that, like using that. It's not like we are always going to deploy the VH or CH onto the cloud. There is a specific use case for that. The point is we can have that deployment. You can download that image. You can deploy that VH or CS device onto a ESXi server, and you can just redirect the traffic via that server. No need to purchase the dedicated hardware for the same. So based on the use case, either you are going to purchase the dedicated hardware, or you can run that as on a subscription basis, maybe onto the cloud. Or you can deploy the controller, you can deploy that VH or CS device directly onto the cloud on AWS Azure. Completely fine. But that will completely be dependent based on the use cases. It will be completely dependent based on the topology that you want to achieve. They have centralized the management plane functionality. They have centralized the control plane functionality, and data plane remained as it is onto the devices. But that doesn't mean we cannot have the management plane functionality or the control plane functionality locally onto the device. I will show you later on that the VH device and the CS device, which we call them manage router in the SD-WAN, even if they are not connected to any controller, they can still be, in fact, fully functional. They can still run the routing. They can still run. They can still be managed via some out of band management system. You can still run the protocols locally and everything. Completely fine without any problem. This solution is cloud hosted and delivered. We can deploy the controllers onto the cloud. In fact, we can also run these, VH or CS devices onto the cloud, but that will be completely dependent based on the requirement. In certain situations, it might be preferred that instead of deploying the VH router or the CH router, onto your premises, it might be a good idea to just go for a subscription base like just deploy or run the controller, run that VH or CH router on a subscription base, maybe, for example. So in that case, we are going to deploy that onto the cloud. Your SD-WAN is application aware, means that it can recognize, the SD-WAN can recognize different applications that are running. And based on that, it can choose a path that has low latency, low loss, and low jitter, maybe. You can see from the vManage graphical user interface, you can see exactly what application is consuming how much bandwidth, what application is facing loss, latency, and jitter, or anything like that. You have that visibility, and you can enforce some policies to be compliant with the SLA of your business. We can enforce some policy that, okay, if this application traffic faces this much loss, latency, and jitter, do one thing, switch to other path. We can create a policy like that. Scalability and flexibility, since the controllers are deployed onto the cloud, we can scale them. We can have one vManage, we can have more than one vManage deployed. Like we can have one vBond, we can have more than one vBond, one vSmart, more than one vSmart deployed. It is very scalable solution. Like let's say your number of users, like they increased like from 2,000 to 20,000. Okay, all you need is to deploy a couple of more. Let's say your devices, not the users. Let's say your devices got increased from 2,000 to 20,000. So all you need to do is to deploy some more couple of like the vManages, and you will notice that you can still manage all the devices from the centralized point. So we can scale as much as we want, and it is a very flexible solution. All you need to do is, if you have deployed the controller onto the cloud, you need to contact the cloud service provider, and you have to ask them that we want to increase the number of vManages, number of the vSmart, and number of vBond to accommodate more number of devices into our infrastructure, and they will do that. They will charge you, but they will do that. All the devices that, when the SD-WAN fabric comes online, all the devices are properly authenticated to each other. The traffic is completely encrypted using IPsec. Segmentation can be achieved with the help of something called VPN. I can completely segment my, for example, one department traffic or my corporate traffic, for example, with the guest traffic with the help of a concept called VPN. VPN is equal to VRF in terms of SD-WAN. We can define variety of access control mechanism. We can redirect our traffic to a firewall, and then from there we can send the traffic to somewhere else. So the integrated security features are available, such as authentication, encryption, segmentation, access control, service chaining. A lot of security features are already integrated. So we sometimes we might not need, for a basic security, we might not need a dedicated firewall for the same. We can use integrated security features that are available onto the CS device, such as URL filtering, zone-based firewall, the AMP thread grid, DNS security. All those features are integrated in the CS devices, unless a very specific filtering or a very specific security is required. You can just use that. You don't need to have a dedicated firewall or any other device for the same. And your existing SD-WAN solution can be integrated with the third-party automation tools. So if, for example, if you are good with automation, you can just create a script to instruct the vManage to do certain tasks, and it will do that. It is open for automation, orchestration, and best-of-breed integration. Like you can integrate your SD-WAN solution with the different third-party automation tool with the help of APIs, REST-based APIs. With the help of REST-based APIs, it can be done. So, and we can transition from SD-WAN, we can transition from the traditional WAN to the SD-WAN seamlessly. All you need to do is to either replace the existing routers with the SD-WAN router, or migrate or upgrade the existing routers into the SD-WAN router, and that would most probably be it. So first of all, deploy the controllers onto the cloud, and then either deploy SD-WAN routers or migrate from the traditional, or upgrade the traditional routers into the SD-WAN router, and you will have all the centralized management functionality with the help of the SD-WAN. So the transition from the WAN to SD-WAN can be done seamlessly. We'll do that. We'll talk about this in the migration. When we talk about at the end about the migration, we'll talk about that. But that can be done. So you can have whatever WAN transport you want to have. We can analyze the bandwidth, application bandwidth requirement, and we can create a policy based on the same. We have different security features such as authentication, encryption, segmentation, access control, service chaining, all these security related features we have. We can analyze the applications that are hosted onto the cloud, how much consumption is there for the applications infrastructure that is hosted onto the cloud. We can simplify the operation from a centralized point, the vManage. We can analyze how capable your network is, or how what things your network can perform, what things your network cannot actually perform. We can analyze all that. So you get the control. The SD-WAN actually gives the control back to the enterprise network, where they can actually analyze all those things based on the requirement and design their network accordingly. So from the architectural point of view, we have a dedicated controller, set of controllers, if I say, and S devices. Set of controllers, vManage, vSmart, and vBond. vManage is the centralized management plane for this SD-WAN solution. vSmart is the centralized control plane for the SD-WAN solution. vBond orchestrates. It is the first point of authentication for all the devices in the SD-WAN. And DS devices, as usual, the VS devices or the CS devices, these devices, as usual, are the routers that we connect at the edge of our infrastructure. IPsec key, about the IPsec and everything we'll talk about later, but just remember that IPsec keys and everything is already there onto the devices. You don't actually need, when the device boots up, it generates the key automatically, and that key is exchanged with the other devices automatically. So that key is going to be valid, of course, for a certain time period. After that, the key has to be renewed. So the re-key process happens here as well. So, but the point remains the same. We don't have to do any configuration of IPsec. I don't need to do any configurations for IPsec. Whatever encryption keys are required for whatever things are required for a successful IPsec connection between the S device to S device, whatever things are required, whatever, for example, encryption keys and anything is required, they are automatically there onto the box. Those encryption keys are exchanged with the other S device at the time of bring up, and then data is encrypted using those keys. We'll talk more about that when we talk about but yeah, those keys have to be renewed. Otherwise, if the attacker gets the access to those keys, problems might occur. So yes, those keys are renewed at a certain time interval, and the re-key process happens for that. These things we'll talk about next later. Again, this is just the benefits of the SD-WAN. What are the benefits of the SD-WAN? It will lower overall the WAN cost. It will reduce the complexity in managing a small, medium, or large scale network. You will have the application visibility so that you know what application is consuming how much resources, and you can maybe apply the policy based on the same. It will reduce the risk because the full mesh IPsec tunnel is there from one device to other device over all the available transport. So the risk of data loss and everything is comparatively low as compared to the traditional network. Since cloud on ramp feature is available, it will give you better user experience. A cloud on ramp for software as a service or infrastructure as a service feature allows us to improve the user experience for different cloud delivered applications or infrastructure. Overall cost is going to be reduced. So we'll talk about all those things. All these are just advantages. You can study about them yourself as well. But these are again all just advantages that we get after implementing the SD-WAN. We'll talk about that in our next class.